Hello, good evening, everyone. I'm recording this portfolio optimization in the efficient frontier. I apologize for the late post of this. I hope this helps you. This is quite similar to the lesson that the case that you're tasked to do. So I provided you the this text file. I'll provide you the text file of this. So first, let's acquire the data. We'll be having 14 assets, quite similar to your case. And we're going to model the log returns of the asset. We're going to create a portfolio, an optimal portfolio. So we're going to use quant mode. These are the packages that we're going to read to use quant mode, QMAO, performance analytics, etc. So these are important for portfolio optimization, these packages. Okay, I will not anymore load it because I have already loaded it. So we're going to use 14 assets, just like in your case. Here we have a list of this object, this character object technology, and it consists of 3 characters: Apple, Microsoft, Google, and these are your technology stocks. And then your consumer discretionary stocks: Amazon, Tesla, Netflix, and so on. You have from financials, JPM, JP Morgan, and Bank of America; healthcare, Johnson & Johnson, Pfizer; consumer staples, Procter & Gamble and Coca-Cola; industrials, Cat and ExxonMobil Energy. Okay, so let's create this. This will create now different objects, an asset list, an object called asset list. Let's take a look at that. So asset list will be under, it will be a list class, list of 7. If we check this, okay, so here's your technology, and then you have your list, the objects under technology. So these are the assets that we're going to use, that we're going to model. And then we're going to unlist these stickers. Okay, we're going to create this object tickers 14, which will unlist it. So let's do this and see what tickers 14. Okay, so tickers 14 is now it's now a character. It's a character class because we unlisted the the object, this object here, asset list. We unlisted it, so we now have a character vector. Then we create this object industry map where we stack this asset list into 2. We're creating a data frame, a data frame where we have the column name should be industry and asset. So if I run this, and this is your industry map. So you have your balik data, no? Okay, let me see industry map. Industry map. Yeah, sorry, I interchanged it. It should be asset first, and then let's correct this class. It should be, okay, where am I here? Okay, this should be asset first. And then this should be industry. Okay, let's run this again. Okay, there you go, asset and then industry. Okay. So we also identify the start date. I'll start with 2018 up to 2024. Let's run this. And then get symbols from the object tickers 14. Where's our tickers 14? This one. Okay. Our tickers 14 is a character vector, if you recall. It contains the, here, the names of the assets, Apple, Microsoft, Google, etc. So you know this, get symbols. Okay, we identify the start date and the end date, and then it will assign the names of the symbols to your assets. Let's run this, and it will generate 14 assets all in all. Since there are 14 there, so we now have these objects here, XTS objects. Okay, so we have 14 XTS objects, and then we can merge the, let's get the adjusted price. We can use a do that call. Of course, you can use the RF function coming from QMOW. Okay, I'll just use the do that call. Merge list apply, get the list coming from the tickers 14, and then perform this function. Get the adjusted prices, and then change the column names of the prices object by the names of the ticker. Okay, so let's run this. So we now have prices 14 here. This is an XTS object because we're using the get symbols. So here, and the name, the column names are the names of that those that occur in the list. Okay. All right. So we get the log returns. Okay. We get the log returns. You know how to use this. Return that calculate, and then method is equal to log, and then we remove the first observation because it will be an A. Okay. So we now have log returns, an XTS object consisting of the log returns of your assets. Where's our log returns? Here. Print this. There you go. 14 assets. Okay. All right. Let me close some of the. Yeah. 14. Okay. All right. Then we can use this in case there are still missing values. You can use this class complete cases log returns, complete the cases of log returns. Okay, this is for the rows and include all the columns. And then let's print paste 14 asset log returns data ready. Let's identify the number of columns. Okay, and then assets, and then the number of rows of log returns, and then days. So let's print this. This is a printout class. Okay, there. So the title is 14 asset log returns data ready. 14 assets of 1,759 days. So that came from the here class. NCOL. Number of columns of log returns, okay, and number of rows of log returns. 14 assets and 1,759 days of observation. And the first six observations here. Okay. Okay. So we'll now go to portfolio optimization. So we said last time that in order to create a portfolio, there are three main steps. First, create this container called your spec. It's short for specification. And then include the constraints there, and then the objective. Okay, and then we perform the optimization. So there are three basic objectives. Okay, I'll discuss objectives in a while. So let's first create our portfolio. Let's call it port spec 14, and the function is portfolio spec. Then assets. Let's use the we have to identify the names of the assets. The assets is equal to the column names of log returns 14. So let's run this. Okay, and we have discussed that this before. Okay, by the way, this is from Portfolio Analytics. Okay, port spec, as we discussed before, is a list. So let's take a look at that class. So far, what are the elements here? Assets, there are 14 assets here. Okay, and notice it defaults into weight, giving it equal weights. Okay, this is of course the default. We did not define the assets to be equally weighted. Okay, but the portfolio analytics package will default it into equally weighted. Okay, so what other things do we find here? You can see here the the constraints, nothing yet, and the objectives, nothing yet here. So we're going to populate this with more elements, like identify the constraints and the objectives. Okay. So then we add our constraints class. Last time we said that there are several constraints that we can we can have. Okay. This one class weight sum, it simply tells us that okay, ano yung weight sum class? If you recall. Sorry. Wala pala akong recitation dito. So we would like the minimum sum to be 99% and maximum sum to be 101%. Now this is done because oftentimes when we are very strict with defining the asset, the portfolio to be full investment, which means that the weight should be equal to 100%. Sometimes the optimization process will not generate a result. So that's why we relax the constraint a bit by allowing that the sum of the weights either be from between 99% and 101%. And then another constraint is that long only, okay, simply means that all the weights should be positive. There should be no negative weight. That's what we mean by long only. No short selling. Okay, when you short sell, you borrow. Actually, you borrow a stock. Okay. All right. Port spec, and then we add more. Another constraint is box. When you say box, okay, we are quote unquote creating boxes for each of the assets. Here we're saying that the asset should not be the minimum weight should be 2%, which means that no asset will have a weight of less than 2%, but no asset will have a weight of more than 30%. Okay, so that's what means. Of course, you can modify that. Okay, or you can give a constraint to only to particular assets, not all the assets. Here, it's for all the 14 assets, at least they will have 2% weight, and none will have more than 30%. Okay, so that's the type is equal to box. Okay, let's run this and take a look at our port spec now. Port spec, where's our port spec? Here. You notice now that port spec consists of 3 constraints now. Okay, these are the constraints that we included, right? This one, the weight sum, the box constraint. You can take a look at this one here. Okay, so this is the weight sum. Minimum sum is 0.99, maximum sum is 101%. It means that when you add the weights, it can be 1.002. Okay, it can be 0.998. As long as it's between 0.99 and 101%. And what's the rationale for that? It will allow the algorithm, the linear optimization to to generate values for your weights. As I said, the imposing full investment, which means that the total weight, the total weights of the portfolio should be 100%. Might be quite restrictive, and sometimes it might generate a no solution. Okay. All right. Then our objective is still. By the way, how about this box constraint class? Okay. Box constraint. What's this? Minimum 0, maximum 1. It means that there can be no negative value. There can be no negative weight. So that's also a box constraint, a type of box constraint. This one, it's also a box constraint where the minimum, notice 0.02, there are 14 0.02s here, which means that each of the asset cannot be less than 2%, and here each of the asset cannot be more than 30%. Okay. So back here. Okay, not four, but 10. Okay, so now we go to the objectives class. Okay. What we're going to do here, class, is we're going to generate a portfolio of balance and rebalance. So first, let's create a model where we're minimizing risk. So we said that there are three basic types of objectives. You can generate a portfolio that minimizes the risk, or you can generate a portfolio that maximizes the returns, or you can have the mean is average, and var variance, which balances between the risk and the return. So let's first draw a model where we're going to minimize the risk. Okay, let's call this object port mean var, and take note it's equal to port spec 14. This is the container class that has the number of the assets, and it has the constraints that we just defined a while ago. So let's create this port mean var, which is typically is exactly the same as port spec. Now we're preserving port spec because we're going to create other optimization models based on our port spec 14, because we're not intending to add any more constraints to the 14 assets in the portfolio. Okay. So with port min var, which is just the same as your container containing your uh, constraints, okay, we will now add our objective. Okay, so what's our objective? Port min var add objective, and our object is port min var, which is exactly our port spec. And then we specify that our type is equal to risk. So when you say risk, then we're actually minimizing it. And name is equal to the metric that will be used is standard deviation. And then maximize is equal to false. So it's the same as maximize is equal to false. We're saying that, well, it's the opposite, no? We're not maximizing, but rather minimizing. However, if we only run this class, the limitation of the portfolio analytics package is that it will not give the returns. Because if you have a portfolio class, of course, you can compute for the returns and the risk. Okay? You can compute for both the returns and the risk. So here, if you only include this, then it will definitely compute for the risk, but not for the return. So we will have to include this also, class. Port min var, add objective, same thing, port min var, type is equal to return, and name is equal to mean. So this is for the report class. Okay, we add this constraint so that we can also extract the returns of the portfolio. Okay, so the final code is to optimize a portfolio. So let's create this object, mean var opt. Okay, this is our minimum variance option, and the function from portfolio analytics is optimize a portfolio. So we have to define the object of the returns. Okay, this is our returns object, log returns 14. we also have to define our portfolio. What's our portfolio? This one. Okay, this one, which contains your specification, it contains your constraints, and it contains your objective. So this one, port min var contains everything here. Okay, then optimized method is equal to random. There are many methods used in optimization class, and one of the familiar ones is random. So it will try to search. It's like going to iterate 2,000 solutions, and trace is equal to true. Okay, so if we run this class, this one, I'll run the whole thing. Okay, so let's see what's min var port here. Min var port. It's a large optimized portfolio random object. Okay, so you can see that. Okay, you have your your R is your returns object, log returns. Okay, so this one now, okay, 199 by 14. What are these class? 14. That pertains to your weights class. You have 199 rows of observation. Okay, and okay, these are the weights. I'm sorry, point 0.03, 0.024, 0.052. Okay, and the objective measures are this one. The risk is 0.01, average daily risk. And then take note, it also gives us the mean. Okay, it also gives us the measure of the returns class. And that's very important because last time what we did was to just do this class. Okay, we only minimized class. So if you recall, when we were trying to extract the mean, we could not because we did not add this. So we should add this class. Add that objective to port min var, type is equal to return, and then name is equal to mean. Okay, this is only for reporting purposes. Because, in any portfolio, you have your risk and return. Okay, but the objective here is to try to generate a portfolio where your returns are very low. Okay, so let's go back to that one. All right, so this is very important class. Under objective measures, you now have two metrics here: standard deviation, your risk, and your average return, your mean. Of course, how do you determine? How do you say if this is okay or not? You have to compare it with the other portfolios. And there is a device called the Efficient Frontier, where you will be able to see which what portfolios are are most optimal. Okay, because you don't have only one optimal portfolio. All right. So these are optimized values, just like above. This is your standard deviation. This is your average risk, daily risk, and this is your average daily return. Portfolio. Okay. So your assets, constraints. These are your constraints. This is what. Well, this is what class. This was generated using uh, port.spec, right? If you recall. All right. So here, as I said, this is our optimization object, minimum variance or minimized returns. And remember, there's an object called objective measures under that object. And this will give us the risk, the standard deviation, 0.01 daily standard deviation, and also the average return. Okay, for that portfolio. Okay, let's now go to maximizing returns. So first we we minimize risk. And this time we're going to maximize return. Once again, we're going to make use of the port spec 14. Okay, we're going to create this object port maxret, and then we're going to add this objective. Add that objective port maxret, this one, which is the same as port spec 14. Type is equal to return, name is equal to min. Okay, but then again, okay, since this is defined first, notice that that will be the default main objective to maximize the return. And then we follow it with the same object port maxret, type is equal to risk, and name is equal to standard deviation. So what will happen is that the model will now compute or print both the returns, which is our main focus, and then also the risk. Otherwise, class, if we don't include this, then we will not have the risk. Okay, so we will now optimize this. Let's call it max return op. Again, the the returns data is log returns 14. Our portfolio is port maxret. Optimize method random. There are other methods, class, but this is one of the most popular. Okay, so let's run this. Let's run the whole maxret. Okay, and you can see here that port maxret op. It's also a it's also like the min var op class. Okay, so let's show this class. And you can see here objective measures, dalawa siya class, 2. Okay, we have the mean 0.004, 0.004279. If we compare this class with the mean var 0.004279, the mean var class, the mean is 0.0004. So the mean class for this for this portfolio is very small, 0.004. But if we're maximizing the returns, it is the mean is 0.004279. This one 0.004 saan na siya? 0.00444. Ano ba to? Wait. This is mean var, no? 0.00444. This is 0.004279. I wonder why this is the solution. Kasi bakit mas maliit pa yung yung average return nito ng maximize portfolio. How about the risk of this? 0.010644. And this one 0.0106. Okay. So the risk of this maxret is higher compared to minimum risk. However, it turns out that despite the fact that we're minimizing risk here, the returns here is even greater. Okay, it's greater. The returns here 0.004279. I think I'm correct. 0.00444. Okay, so that's one thing that may happen. Okay. All right, so let's move on here. The third, okay, you can print this 0.004279 here. The return is 0.00444, 0.004279. So that's really, let's say, a quite weird situation, because in this case we were maximizing the returns, no? Based on our objective type is equal to return. Okay, But here, the return is lower than the solution where we were minimizing the risk. It's 0.00444. Here it's 0.000427. Okay, so that could be considered something as uh, it's not a, how should I call it? Because technically, logically, and theoretically, the returns of maximum return, should be greater than the uh, average return of the minimum variance optimization. Okay, but anyway, let's move ahead. And another way in order to optimize your portfolio is a mixture of mean and variance, risk and return. So if you take a look at this code here, so here we're creating again an object called port mean var, combination of mean, return, and standard deviation or variance, which is a measure of risk. Okay, so and then we add on to this port mean var, we add on, the objective is whatever the whatever the this port spec 14 is, it's represented here in port mean var here. And then, okay, we put first risk, and then name is equal to standard deviation, and then this time include returns, and then name is equal to mean. Okay, and then when we do the take note again, class, we include here both mean and risk, standard deviation. However, when we do the optimize that portfolio, we include something here, which is max SR, which is your maximize Sharpe ratio. So the Sharpe ratio is a measure of return per unit risk. So of course, I'd like to maximize our Sharpe ratio. Okay. Now notice that this one was not included in the port max ret. So we reserved it here for a combination of maximizing return and minimizing risk. Okay. So if you run this, okay, and then let's also get the measures. Okay, so take a look at this class. The mean is 0.00437. It is lower than the 0.00444, the minimized risk here, but it is higher than the maximized returns. So it's actually in between those two values when we're optimizing your both the mean and the risk. And how about the risk class? The risk of this here, let's compare it with the minimum risk. 0.01048. Okay, 0.01048. While here class 0.0107. Okay, so what does this mean? This portfolio will be a value between your maximum returns and your minimum risk. Okay, so that's what we found out here. Okay, let's verify the results. So this is just printing minimum mean var, which is your risk minimization. Print natin yung the round of the extract weights of our object. Okay, and then we compare it with the maximum returns and mean variance. Okay, so let's run this. Okay, so if you run this, then you also include the the results, no? Minimum variance of maximum ret opt, and then mean variance opt. Okay, we get objective measures. Okay, objective measures, the mean. So it will print this one. All right. I'll rerun it. Okay, so what do we have here? What are the weight comparisons if you're using minimum variance? So Apple will have 3%, Microsoft 2.4%, etc., etc., etc. So this is how you craft your portfolio if you would want that the risk is minimized. Okay, the highest weight we can see here is Procter & Gamble, 24%. How about if you want to maximize the returns? Now, of course, when that happens, you would want to saddle your money in the highest returns that in in the asset that produces the highest returns. So you notice here that Procter and Gamble and Pfizer, Coke, also Coke, they seem to be the highest. Okay, and how about for mean var? Okay, you have different weights. So you can see here that the mean. Okay, we should have uh, this is four it's for the how many decimal places? 0.0004 something. Okay, that's the returns. Okay, so based on scientific notation, halos pare-pareho lang. What's different is that the risk, the mean var, and of course, minimum variance will give you the lowest risk. This had the number been printed, we would have seen which is the uh, portfolio that gives us the highest return. Okay, all right. So I hope that that's clear about using your portfolio methodology, optimizing portfolio method. First, you, of course, you load your assets. No? After getting the returns of the asset, log returns, after cleaning your data, then okay, we now perform the first step for optimization, where we create our spec. We create a container where we put the optimization parameters. Okay. So here, let's now go to quarterly rebalancing. Okay. So let's not make it monthly balancing because that can be quite expensive. Let's just use quarterly balancing. Okay. So here, I'm creating now another another object here. Okay. Mean var opt rebalance. So we can use the returns. We have the returns. Our portfolio is our mean port mean var. So this is a combination of this is the portfolio natin, di ba? Port mean var. And then we optimize. Okay, just by way of review class, baka nakalimutan mo. What's port mean var here? It's a list of 7. Ano laman ni port mean var? Okay, if you recall class, ito siya, di ba? Hindi yung, dapat yung MIN, minimum variance here. Port mean var. Okay, we have the assets. Yan, 14 assets natin. And then we have the constraints, the objectives, di ba? Ito. Risk and return objectives. Okay. So What were we running now? Okay, so this is now rebalancing class, no? Rebalance on quarter. Okay, rolling window is 60. Okay, it means it will compute for the risk and return of those 60 60 dates. Okay, so this is we're using quarter class because pag monthly will be generating so many portfolios. No? So pag quarter lang every 3 months, let's run this. Okay, so this is minimizing risk, no? Kasi ang ginamit natin class yung port min var, no? So it's taking some time to okay, generate, and then class we extract. So this is min var opt rebalance. Let's take a look at this class. So very huge memory ang kailangan, no? Okay, so take a look at this class. So these are our returns. Take a look at our optimal rebalancing there. So you notice the dates class every 3 years because we said that it should be quarterly. So you'll have a solution class every, 3 months because this is daily data. For example, what's our data class starting with January 1, 2018. Okay, so for the first quarter, it will be March, end of March. So what will that include? It will include this portfolio class. So it will have its own portfolio. Okay, so each of the rebalancing class will have their own, they will have its own portfolio. Okay, so next quarter, etc. Okay, so if we're using rebalancing, it will generate. Let me show you class. Okay, just a sample. Okay, so let's get this opt rebalancing. This will take a few seconds because it will print here class. Okay, mabilis na kasi narinan ko na ito kanina. No? So for March 29, okay, what's the date here? This is March 29. These are the optimal weights. Apple is 2.6, okay, which is the biggest one. 8.8 itong Pfizer, no? Ito sabi yan. Ando pala itong 28.6, Procter & Gamble. Okay, that's where you will load yung weight. No? Notice walang greater than 30% and nothing greater than less than 20%. Ito lang almost 30% na. Si Procter & Gamble. And then you have the next quarter. All right. So the notice here, standard deviation is 0.006, mean is 0.0057. These are quarterly averages. There's a previous one, 0.012, 0.002. So every quarter, you're generating these values of your portfolio. This is 0.006, which is better. This is 0.01. So the performance of this one in terms of risk minimization is better. Kasi mas maliit yung standard deviation niya. In terms of average 0.0057, if we compare it to the previous 0.005, the second quarter is also higher. All right, so it lists down all the quarters, class. How many quarters? 29, I think. All the 29 quarters. Okay, so let's now go to rebalancing, but this time you'll generate the same results, class, if you're rebalancing. Ito, no? Maximum naman to. Max, ret, opt, maximum return, uh, optional rebalance, optimization, and then rebalancing. You can see here that it's no longer the portfolio is port max ret, not port min ret. Okay, same thing. Okay, so let's generate this. Remember this rebalancing. And then okay, I'll not print it. Okay, I'll not print it anymore. Pero makikita nyo, class, that the results are also based on, let me just do that. Oops, sorry. It hasn't finished running. What happened here? I haven't run this, sorry. Here? What did I run? Wait, I'm sorry. We're done with that. This is your, this is the this is the maximization already. So same thing, class, you notice that you have 14 weights for the 14 assets. Okay, for every quarter. So that's what happens when you rebalance. It will now create a new portfolio on a quarterly basis. There we see 21, 12, 31. Okay. So this is quite long. I'll browse through it. Okay. And then what's this one? This is supposed to print it. Okay. This is yeah, I mentioned here that there will be values of risk and return. Okay, and then this is for the balancing of the risk and return. Okay, so we're using here port min var also, but take note here that we impose if you're mixing your risk and return, then you have to specify that the Sharpe ratio has to be run. And again, class, it will generate the same thing as above. So I'll not run this anymore. I'll run the, it will generate now portfolios every quarter, and that portfolio maximizes your Sharpe ratio. Sharpe ratio is your risk-adjusted return. It's equivalent to your R, your return, divided by the standard deviation, the risk. So it's return per unit risk. All right, and then last, which is required also in your case, is to create the efficient frontier. Okay, so I have purposely given you here the codes by which you can create your frontier. So first, let's create. Let's use the existing portfolio spec natin. Okay, so here we're creating an object called portfolio F frontier. We're going to add the objective. Okay, this is our import spec 14 natin. Ito yung nasa taas natin, di ba? Yung spec ano natin, object. And then you have your risk, name, standard deviation, and then you also add your return, name, mean, in order to be sure that it generates also the returns. Okay, then here is your function for your efficient frontier. The function is create efficient frontier. Okay, so dito ginagamit yung quad prog class, no? Quadratic programming. All right, so let's run this. Okay, then we can, let's just extract yung sa ano, no? Para maging part ng portfolio points natin kasi we're going to plot here the portfolio, the efficient frontier, no? We'll create an object called mean bar, and it's the extract, create, extract objective measures from mean bar port, opt from maxret opt, and for MV opt. Let's assume that the uh, risk-free rate is 2%. Okay, so this is 2% yearly. So you'll have to divide it by 252 to make it, because our data is daily, to make your data daily. So I'll run this. Did I run this? Anyway, and then I'll run this. And also the port, the point of tangency. Okay, I'll not discuss, but objective lang siya, no? They're just objectives. And here we're introducing some type of objectives. Okay, where we identify the name is equal to Sharpe ratio. Okay, so let's run this tangency. Okay, and then plot. Quite a long code. There you go. So this is our efficient frontier. Okay, what's important here, class, is that, okay, asan na yung annotation ito? Okay, so you can see here the efficient frontier. Sorry, it normally looks like that. Plus, this is your tangency line. Okay, you can see here that Tesla is here, Netflix is here. Okay, so what's important here, class, is that you have individual assets here. If you take your individual assets, uh, bali, pag individual kasi class, no? That's not a portfolio. Okay, but if you have a portfolio of assets class where you mix the all your assets into one, then there will be combinations that will fall under this one, this efficient frontier. Okay, and what's the use of that? If you compare the assets on this side class, okay, so this is your return, this is your risk. Okay, sorry for my example here. Okay, if you take a look at this asset and compare it with this asset class, notice here, okay, lumampas na pala ako ano. I just, sorry for the example, no? Let's say like that class. No? So at this point, uh, okay, this is every point here represents a portfolio. Every point there. And then you can see that in the efficient frontier class, oh boy, in the efficient frontier, okay, this one, this curve here. Oops, sorry, huh? But we just erased so many. Okay, let me repeat. Here. This is what you call the point of tangency. And if you take a look at your at any asset in your portfolio, For example, this one. And compare it with all the any asset here in this line. So you might have, uh, say we have several portfolios here, and one portfolio is here. If you compare it with this one, plus this asset has these returns. This one. And what's the risk? This is the risk. Measure the standard deviation. Okay. Now take a look at this. The return of this asset is this one. While this asset, the return is this one here. Okay, but they have the same risk. So you have two assets, let's say asset portfolio as portfolio A, portfolio B. They have both the same, let's say, let's make it 0.018 daily. They have both a daily risk of 0.018. However, asset portfolio A has this return, while portfolio B has this return. So you can see there the discrepancy between asset A and asset B. So the efficient frontier tells us that those assets that fall on this line are the most efficient ones. Okay, those the assets that are just scattered abroad. Okay, they're just scattered there. You'll know that there will exist an asset. Say this one. If you have this asset, there exists an asset I here, so that so there exists this as an one. There exists this asset I here. If we're here, there exists an asset that has a higher return than you, and at the same time, you have the same amount of risk. Okay? Iba pareho lang yung risk nila dito. All right. So, in a nutshell, that's your efficient frontier. Escape. Mag-escape lang. Sorry. Clear pa lang muna. All right. So that's where your case actually ends, for you to be able to create your efficient frontier and then and then describe your efficient frontier. Okay. So be able to identify what your portfolio is, if you're choosing minimum variance, of if you're choosing maximum returns, what will be your portfolio. Okay. If it's not rebalanced, then it's very straightforward. The the rebalance has a different output because you will create portfolios uh, every rebalancing. So if you have monthly rebalancing, that means that the X number of months it will have a separate separate portfolio. Okay. Okay. So with that, I end our discussion. I hope this helps in your case, and I apologize for post posting this quite late. I'll give instructions on how on your how to submit your cases. Okay. Thank you.